Can you hear me? Can you hear me? Hello? I hope this seat will be enough today. Can you hear me? Can we hear me? Please send message to the WhatsApp group that they should answer me on YouTube. I'm already on live. Those one that have joined, I said, can you hear me? Can't you just answer me? Be fast. Okay. All right. Then. All right. Very good. Just we are starting in a few minutes time. Okay. I think they are coming. So if any of you have any questions as regard to anything I'm doing, just drop a message on the WhatsApp group. So someone will respond to me here. Someone will say it. I hope you can what I'm saying. If you have any question, because I won't be with this phone and I may not be checking the moment you're asking your question, drop it on the WhatsApp. So someone will communicate it to me here. Then I will attend to it. I hope we understand. So we are starting first time now. Yeah, we are starting. Let's start. Boss. Can you see the board? Topic in it. Can we see the board very clearly? Okay, all right. And we can hear my voice. Okay. So, what should we start with? Physics or math?
Physics.
People are ready, please. People are ready. Some of us are here that if you are here, you are not doing math one notice. Can I say? If you are here, you are not doing math one notice. People are actually ready. Do you know what's funny? Did I tell you what's funny? It can be sent out from here. Don't stop your noise. And that's what's funny. So please just lower the voice. If you are here, you are not doing physics. Can I see your hand? You are not doing physics 101. So no one has. That means we are all doing physics. But we are not all doing math. So let's start with physics then. Since we are all doing physics, don't worry, I won't spend much time on physics. Since the thing is that we are all doing physics, but we are not all doing math. So let's just start with physics so that physics people can go and see. Okay, some of you are like, this is a simple direct. Let's just start with math, bro. The physics is not simple. So last class we started with dimension and we entered vector. So we continue from vector now. And I'm also thinking rather than doing it that way, I'm coming. Let me just. Rather than doing it that way, probably we just focus on questions. Then we'll be using those questions to explain many things you might need to understand. So, one of you should just check the WhatsApp group. So those link I sent, I think 2 days ago to the group or yesterday. The one with physics, one past questions here. Just help me to open it. Just open it. So as we are choosing a question, before we move to another question, we also check things that are related to them. Do we get that now? Are we okay with that? Or we should do topic by topic? All right, let's open the question. Let's open the question. Let's see if there is any vector questions here. Let's check. We're actually on vector, so let's see how we can balance it up. I hope you know the link I'm referring to. I sent it to the group. I think I sent about 6 links to the group. Is this on sending fire? Right? You guys just send a message to the group. Others should join. This thing is not lagging. Okay, all right, good. Who has opened the Google Drive, the link? Please don't sleep. This is not the time to sleep. In fact, we have not started. I heard that your visual number is not BLC. They have changed it out. I thought as much because I was like, but only you had the. Is it the same day with 103? I think it used to be the same day now. But I can't remember that one. But I shall know it's always there. When I saw CBN, I feel 101. No. Share correct exam. But this one that your maths is not DSCE. Yeah. Guys, go and pray. Okay, let me just mark it. Not that I'll just be eating something like that. So on vector, let me just mark out the question that are based on vector. So it's not even much. Probably use the slide like that. So let's just let's start with that question 20. When we are done with this, we go to the slide to treat more questions on vector. Let's start with that question 20. What's the question? Can you read it?
F equals to
F
equals to brackets, open brackets, 5i plus 3j plus 2k, close bracket. Move particle to p. Move particle to p.
It moves particle to
P
to P
equals to 2i minus j. Find work done.
So we have to find the work done. So this force is applied on a body to move a particle from a point to another point P. Are we together? So we have to find the work done. Actually, the compilation of the question is not balanced. So it actually moves the particle from origin to this point. Are we together? So it moves the particle from origin to this point. Okay, like I said the other time, for work done is not equal to force times distance. I hope we know. There is nothing like this in physics. Work done is force times displacement, not distance. Please take note of that. Force times distance is not equal to work done. It's force times displacement. But in chemistry, you can see force times distance. But don't worry about that. Now, why am I saying this? Because if you are given 2 points, let's say point A equals to so, and point B equals to so. If this force moves this particle from this point to this point, it's the difference between the 2 points that I want to multiply with your force to get your work done. Are we together? The difference between the 2 points, which is the displacement. Do you get what I'm saying?
Yes.
But there are some questions they would have given you displacement. They will say a force moves a particle through a distance of. No, they mention distance there, but that's actually a displacement. So when we are referring to it, like here now, we are just talking about straight line. No, in a straight line, distance equals to displacement. So here now they said a force move a particle through a distance, like let me say through a distance of 5 meters. So probably start from origin to 5 meters, and it may not even start from origin. It may start at 0.5 to 10 meters, but you are not concerned with wherever the particle is starting from anymore, since you have been given the distance that was moved already. I get what I'm saying. If you have been given the distance that was moved, like moved through already, you are less concerned with whether it starts from origin or not. When if they say a particle, a force moves a particle from point A equals to 2I plus j minus k to point B equals to I plus 2j minus 3k, and you are given the force, find the work done. Since it's moving it from this point to this point, you just subtract to get your displacement. Are we together? So the distance that is being moved through. But if they say a force moves a particle through a distance, let's say s equals to 5I plus 2j minus k. If you are told that the particle starts from the origin 0,0,0, or probably start from 1,2,3, or maybe it even start from 3,7,6, these are IJK. You are less concerned with all this, whether it's starting from origin or not, since you have been given this directly. Do we get what I'm saying? So when you are given this directly, the distance that was moved through, just use it as your displacement. But if you are not given, if you are given 2 points, just subtract to get your displacement. I hope that's clear. So that's that for that. Now we have been given. Please help to read the question again. Let me see. Okay, the question says that it moves the particle to this point, right?
Yeah.
So not through this point, not through this. Are we together? It's to this. So me, I thought because it's not stated there whether I start from origin or not, but let's just use the part that is starting from origin. The question was extracted, so everything is not complete. So since it's starting from origin, let's call the origin point P1 is 0, 0, and let's call this point P2. Are we together? So now to get our displacement, that will give us what? P2 minus what? P1. And that's what? 2I minus j plus what? 0I, minus 0I plus what? 0j. Are we together? So, and we don't even need to do this. Since it's starting from origin, this guy equals to our displacement. So I'm just showing us that in case it's not starting from origin, you are just going to subtract. So we still have what? 2I minus what? Minus j. So now, our work done equals to what? Force times what? Force times displacement. The work done is a scalar quantity, so I don't need to put direction here. Are we together? But force is vector, displacement is also vector. So what's our force? 5I plus 3j plus 2k. I don't forget, sorry, we are using dot product because it's a scalar quantity, isn't it? Dot 2I minus j. Since there is no k here, what do you do? It's 0k. So for dot product, multiply this, and multiply this. 5I times 2I, 10I squared. You can use the quotient alone because I squared is actually 1. Am I communicating? Under dot product, I squared is 1, j squared is 1, k squared. Since if you have I times I equals to 1, j times j times k equals to 1. Is that clear? Also, I times j equals to 0. Like if they are not the same, the answer is 0. Are we together? If they are not the same, it means they are perpendicular. That's 90 degrees. And what's cos 90? No, for scalar, you are using cosine. I hope you remember. Work done equals to fs cos theta. Do we remember? So you are using cosine. So if ij, that means they are perpendicular. So that means our theta is 90. Cos 90 is what? And if it's also jk, That's still 0. But if they are parallel, that means the angle between them is 0. What's called 0? That's why we're having 1 here. Do we get what I'm saying? So that's that for that. So for this one, we have 10I squared plus what? 3j times this. That's minus 3j squared. 2k times this we have plus 0k squared. So this guy gives us 10 times 1 minus 3 times 1 plus 0 times 1. And that gives us 10 minus 3 plus 0. And that's what? 7 joules. I hope that's clear to everyone. Any question?
What's, I mean,
Are we following those who are online? Are we following? Okay. Can we see the board very clearly? You are seeing because you are asking if this is smart one or two. Pẹ̀lẹ́. Now, what's question 25?
R equals
Huh?
R equals to
4i
plus 5j
plus 5j
plus 6k.
plus 6k.
Then S equals to
S,
yes, 2i
2i
minus j
minus j
plus 4k.
plus 4k.
Find U equals to R minus S
Oh, good. Find u equals to r minus s
and U dot S.
and u dot s. So after this, I'll just go to the slide and treat some resolution of vector stuff. All those ones that involve arguments. Are we together? Now r equals to 4i plus 5j plus 6k. S equals to 2i minus j plus 4k. Find r minus s. So our r minus s equals to 4i plus 5j plus 6k minus 2i minus j plus 4k. And that gives us 4i minus 2i. 5j minus j. 6j, that's 5j plus j. 6k minus 4k. And this is what? Our u, right? So now we have to find what? U dot s. And it's very easy to make mistake in this question because if you are not coming, you still be doing r dot s. Are we together? I think it happened to some people last year during my one rest test, I think. So it's the answer that you obtain that you have to dot with s. So now our u dot s equals to what? 2i plus 6j plus 2k dot, what's our s? 2i minus j plus what? 4k. 2i times 2i, that's 4. 4i squared, and I squared is 1, right? Plus what? Minus j. That's minus 6j squared, and j squared is 1, right? Plus 2k times 4k. That's 8, isn't it? So we have 4 minus 6 plus 8, and that's what? 12 minus 6, and that's what? That's 6. So our answer is what? 2i plus 6j plus 2k plus 2k, comma 6. You pick this option, you are wrong, bro. This is wrong, this is correct. But this is the first thing they ask you, so you have to arrange it. Are we together? But both can be in the option. Somebody is saying that. Both can be in the option. I think both were in the option during my first test last year. This is there, this is also there. Now let's check some questions from the slide. All these one are, we see me this one at the front, so please someone should open the slide. Let me. Okay, let's just start with this. three forces act on a body. Three forces F1 equals to F1 equals to 20 Newton 30 degrees southwest. F2 equals to 15 Newton 40 degrees 15 Newton along east. F3 equals to 30 Newton 60 degrees east north. Act on a body. Find the resultant force in magnitude and direction. Find the resultant force in magnitude and direction. Are we done? So now let's start with F1. We have to resolve F1. So how do we do that? Let's draw our axis. So here we have F1 equals to 20 Newton 30 degrees southwest. And I think I've told us before that if you are given southwest, the same thing as west or south. Do we remember? And this means the angle is coming from where? South. Are we together? Whether west or south, the angle is coming from south. Southwest, the angle is coming from south. If it is west south or south of west, that means the angle is coming from west. East north means the angle is coming from east, which is same as north of east. So just those things are very important. You need to know them. So here we have 20 Newton 30 degrees southwest. So here we have our north, south, west, and east. So 20 Newton 30 degrees southwest. So we are coming from south. This force is coming from south. So let's say these are 30 degrees. Are we together? This is the angle, 30 degrees. And this is the force. When the force got to 30 degrees, stop. So we have the 20 Newton here. So close it. Are we together? So we need to find part of this force that belongs to the horizontal component and part of the force that is what? Vertical component. Are we together? So here now, using our SOCAD, so I've got this a right angle triangle. If we want to find the horizontal component of this force, what are we going to do? So, right? Why is it so? Because the fx is opposite to the angle. And we know that sin theta equals to what? Opposite over what? Hypotenuse. And that gives us what? Our sine, what's our theta? 30 degrees. What's our opposite? Fx. What's our hypotenuse? 20 Newton. If you cross multiply, what's fx? 20 sine what? Because x is the same thing as the y-axis, isn't it? So we had our I component there. No, y is j, x is I. So fx is 20 sine 30 I. But let's check, is it on the positive x-axis or the negative x-axis? Is this negative x or positive x? Negative. So this we are going to attach minus here. I hope that's clear. Now let's find our fy. So fy is adjacent to that angle, isn't it? So for adjacent, we are using what? Car. So cos theta equals to what? ADJ over what? HYP. And cos 30 equals to what's our ADJ? FY. What's our HYP? 20 Newton. If we cross multiply, that means Fy equals to what? 20 cos 30 J. Because on the y-axis, that's why we are adding J. Is it negative y or positive y? So we are adding minus. So our F1 now, our F1 equals to what? Fx plus what? Fy, which is what? Minus 20 sine 30i plus what? Minus plus and minus, we still have minus, isn't it? 20 cos what? 30j. This is our F1. Is that clear? Now for our F2, because our F1 is not acting in a single plane, it's acting on both x and y axis because it's slant. If I give you something like this, if I have a graph like this, and if I'm moving like this, I'm actually moving on both x and y axis, isn't it? Because if I get to this point, that means I've covered a distance from here to here related to the x axis. I've covered a distance from here to here related to the y axis, isn't it? So if I'm to trace this point to the y axis, that means I've covered this height. If I'm to trace this point to the x axis, that means I've covered this length. So if I'm moving like this, I'm moving on both x and y axis. Do we get? So since the force is slant like this, that's why we have to resolve it to both x and y axis, which we just did. So for our F2, we have 15 Newton along east. So this one is only moving on a plane, on a straight line, horizontal line to be precise. And east is it positive x or negative x? Positive x. And that's I, right? So here we have what? We have our F2 now is what? 15I. Are we together? Because on the x-axis and it's positive, that's 15I. Now for our F3. Now let's work for our F3. For our F3, we have 30 Newton, 60 degree east north. That means the guy is coming from where? From east or from north? From east, right? So, and that's what? 30 Newton. 30 Newton. 60 degrees. So there is horizontal axis and there is what? Vertical axis. Now let's resolve to horizontal. Our horizontal axis, is it opposite or adjacent? It's not every time, because some of us, we are used to the fact that our sign will always go with I. It's not every time your sign go with I. You can have cos attached to I. Like this one we have here now. Our fx here now, which is the I-axis, is adjacent. So we are using cosine, isn't it? So just if you can draw this thing very well, you don't have issue with what you write here. Just draw it very well. Just interpret it very well like this. Initially, even me doing my 100 level, I used to use, even there was a time I was teaching, so I said, always attach I with your sign. But that same day, I later corrected it, like J with your cosine. But that's very wrong. It depends on the structure, on your interpretation. Am I communicating? So as you are assuming this is not east, I would have gone with sign. But the fact that it's east not, so our fx now is adjacent to the angle, which is car. So we have our cos 60 degree cos what? Adjacent over what? Hypotenuse, right? Hypotenuse is the first sign. Cross multiply. What's our fx? 30 cos what? 30 cos 60. And is it on the positive x or negative x? So here we have 30 cos what? 60i plus. Now let's find our fy. Our fy is what? Sine, are we together? Which is also on the positive y-axis. Plus what? 30 sine what? 60j. So we are done with all those stuff. Now let's begin to punch our calculator. So for our F1, sine 30 is what? 0.5, right? 0.5 times 20 minus 10i, because we have negative there. Because 30 is root 3 over 2. That's 0.86 times 20. 0.86 times 20. That's what? That's 17 point what? 0.34. 0.32J. Our F2 equals to 15I. What's our F3? Because 60 is 0.5, right? Times 30, that's what? 15I. Times 60 is 0.86 times 30. 25.98, right? J. Now, our F total now is going to give us what? F1 plus F2 plus what? F3 is what? Minus 10I minus 17.32J plus 15I plus 15I plus what? 25.98J. Are we together? Minus 10I, 15I plus 15I minus 10I. So our F total equals to 20I. 25.98J minus 17.32J. What do we have? That's what? 8 point what? 8.666. Yes. 8.66J. So these are F total. Now let's find the magnitude. Square root of coefficient of I, you square it. Coefficient of J, you square it. And that gives us root what? 400 plus, what's root of this? I mean square of this. That's close to 80. I mean, what square of 8.6? 70 plus 400. 474.99. We have to take the square root. 21.79. 794. 75. 755.
795.
Okay, 795. Let's just say 21.8. Abi? Right? 21.8 Newton. So that's the magnitude of the force acting on the body. Is that clear? For the direction, we are going to use theta equals what? Tan inverse of what? Y over X. What's our Y? Coefficient of J, which is what? Tan inverse of 8.66 divided by what? And that gives us what? Tan inverse of 8.66 over 20. 0. What? 43. We have to take the arctan of it. 23.41 degrees. On which quadrant? On which quadrant? Now check your F total. Your J is positive, Abi, and your S is also positive. J positive, S positive. That's on where? First quadrant. So you need to add the quadrant. On the first quadrant, to the x-axis or to the horizontal axis. On the first quadrant to the x-axis, take note of that. On the first quadrant to the x-axis. So that's that for that. And even though if there is minus here, you don't have to put the minus here. If you have negative here, just still use 8.66, but the negative will give you the quadrant. Am I communicating? So that's that for that. So, but in case they are not using quadrant in the option, if you don't use quadrant in the option, make sure you use the negative here. Am I communicating? So if you use the negative here, this one will be giving you negative, which should be your answer if quadrant is not stated. Are we together? But if quadrant is stated, you don't have to use the negative because the negative is already used to determine the quadrant. So it's like you're applying the negative twice, which you shouldn't do. So you can only use this negative here and have negative here and leave it that way if quadrant is not stated in your option. Am I communicating? I hope we all understand. So let's put it down before we move to the next question. And if you have questions, please feel free to. Can we see what you are doing? Those who are watching online, I hope we understand what you are doing. Hello, are we there? I hope I have not slept. Hello.
All right. Good.
Can I clean the board? Are you sure? Well, let's treat okay, someone should open the slide. Let's check. Let's read some vector questions in the slide before we move on to the next aspect. Just someone should open the slide. Let's read some vector questions, some questions on vectors. And okay, before then, just keep opening it and keeping the questions. You all know some of us we know this thing we want to do during the test, but after the test, we have forgotten. So let me just do it briefly. Multiplication of vector. As long as I can remember, I think we have 3 types of multiplication, right? A vector by a vector. If you multiply a vector by a vector, it can either yield a scalar quantity, isn't it? Or what? Or a vector quantity. Let me write it. It will also be a vector quantity. But a vector by a scalar, this is always what? This is always vector. When you multiply a vector quantity by a scalar quantity, that's always vector. And if you want to do the type of quantity you are dealing with will determine the type of multiplication or the type of product you want to do, whether it's dot multiplication or cross multiplication. For instance, if what I'm asked to find is a scalar, so I'm going to use dot product. Scalar for dot product or scalar product. While vector for what? For cross product. This is the sign notation, cross product. This is the sign notation. So for instance now, let's say work done for instance. Okay, let's start with work done now. Examples of a vector by a vector that give a scalar quantity. E.g. work done. Vector times vector that yields scalar. E.g. work done. So we have different ways of finding our work done. It depends on the parameter we have in the question. For instance, work done equals to what? F dot what? F dot S, right? Which is also same thing as what? Magnitude of F multiplied by what? Magnitude of S cos what? Cos theta. I think there is one more. Or these are the two. Okay, maybe if there is one more, so that's that. Now, if you are asked to find the angle between the force and the displacement, if you have to find the angle, but you are giving your F a vector from ij or ijk, and you are giving your displacement same pattern. So you just need to use this one to first of all find your work done. Then you can equate that work done equals to F S cos what? Cos theta. Since you already have your work done using this guy, then you have been given this guy in vector component, to find the magnitude using this pattern, then make cos theta the subject of the formula. Cos theta gives what? W over what? F S. So that's how you get your angle. So all this, there's no problem about this guy. And also what you also need to know is that I'm trying to remember that I'm coming up. There's
You said something in the question before.
I hope it's not this. How much? How? I'm coming. I'm coming. Oh. Okay. Okay, I hope the board is clear.
So now if okay, I think I can remember what. If you are given two vectors, let's do something like this. If A equals to 5i plus 4j minus xk, and B equals to 2i minus j plus k. Find x if A and B are perpendicular. I hope we are not, this is not, like we are familiar with questions like this, isn't it? If A is this and B is this, find x, this value, the coefficient of kx, if A and B are perpendicular. And now when two vectors are perpendicular, what is their scalar product? If two vectors are perpendicular, what is their scalar product? Is 0. Because no scalar product goes with cos theta, right? And then they are perpendicular, what's cos 90? So if you are doing this is if you are doing scalar product, A dot B, what am I even saying? Yeah, A dot B equals to, sorry. If you are doing scalar product of this guy equals to, let's say A dot B equals to A B, right? Cos what? Cos theta, just like the one we applied to work done earlier. Are we together with this? A dot B equals to what? You know, earlier I say work done, this is not work done, I'm just equals to this S cos theta. I also say the same work done equals to this guy, isn't it? Am I communicating? So this is just like the one we are writing here. This is vector. So this guy equals to this guy. Since this, so just coming from this idea. I hope everybody gets what I wrote here. So A dot B equals to magnitude of A times magnitude of B cos theta. And since A and B are perpendicular, that means this guy is what? What's cos 90 is 0. 0 times whatever we have here. So A dot B will give us what? Is 0. So that means their scalar product equals to 0 since they are perpendicular. Which means if we dot these two together, we equate our answer to 0 to get the value for x. Now let's do this. 5i times 2i. That's 10, right? 4j times minus j. Minus 4. Minus x times minus xk times 1k. That's minus x, right? Equals to what? So here we have 6 minus x equals to what? That means x equals to what? Is that minus 6 or 6? X equals to 6. So that's the value of our x. What if they are parallel? What if they are parallel? How do you find the value of x? We equate it to what? To 1. No, we are not equating to 1. If they are parallel, are we equating to 1? No. This is it. This is how it is never. If you have A dot B equals to what? Magnitude of A multiplied by magnitude of B, because since they are parallel, that means the angle is 0. It's called 0 that is 1 here, not everything. So you can't equate to 1. Do you get what I'm saying? Yeah. So if it is parallel, I cross product to find the value for your x. If it is parallel, to use dot product will be very difficult because in fact you can't even find the magnitude of your A. because x will still be there. Do you get what I'm saying? And you have to find x. So you can use cross product. If it is parallel, what is the cross product? For parallel, cross product equals to 0. Let's confirm that. For A cross B, I think that should be sin theta, right? If I'm not mistaken. And if they are parallel, that means this will be sin 0. And multiply by whatever we have here, that gives us 0. So if they are parallel, use cross product. Are we together? If they are perpendicular, use dot product. Equal to 0 by using dot product. If they are perpendicular, equal to 0 by using cross product. If they are parallel. Do you get what I'm saying? So now, how do you do your cross product? Now, assuming they are parallel, let's do our cross product. So here we have so using your matrix method, I, J, and what? What's the coefficient of I there? 5. The second one is what? 2. This one is 4 minus 1. Some people have even forgotten matrix. This one is minus x, are we? And what? 1. Are we together? By putting, and please don't make mistakes, by putting something like this is not magnitude. What is here is determinant. You know, if I say A, B, C, D, it's not equal to A, B, C, D. This is just the matrix. This is the, by putting this straight line, it means I'm finding the determinant of the matrix. Are we together? So by putting straight line, I'm looking for the determinant, which is not the same thing as A cross B. This one is magnitude of A cross B. This one I wrote here is just A cross B alone. Am I communicating? Yeah. This guy now if I want to do this, it's like this now. Do we get? If I want to do magnitude of A cross B, I'll now put magnitude here. Do we get what I'm saying? So writing it like this alone is just A cross B alone. That is, I'm finding the determinant of A cross B. So that's now let's look for the determinant. So for matrix, in matrix we used to shoot gun, and that gun is straight bullets in all directions. So if this guy shoots in this direction, there is nothing to kill. You shoot in this direction, nothing to kill. You shoot in this direction, it's going to kill 5 and 2, right? You shoot in this direction, it's going to kill what? J and K. So what do we have left? So when I shot is gone, only 4x, 1 and 1 survive, right? So we have 4 minus x minus 1 and 1. Are we together? Do we get what I'm saying? Yeah. So, and for matrix, the sign always go with this plus minus plus minus plus minus. So the first one is positive, the next one is what? Negative. So that's your gift. When you get shot its own gun, killed I, killed K, killed nothing, killed 4 and minus 1. What do we have left? 5 minus x, 2 and 1. 5 minus x, 2 and what? 1. Then plus K. When K shot his own gun, killed minus x and 1, killed J and I. What do you have left? 5. This direction, killed nothing, killed. We have 5, 4, 2 and minus 1. 5, 4, 2 and what? Minus 1. Now here we have I, 2 by 2, cross multiply, right? 4 times 1 minus, 4 times 1 is 4, minus x times minus 1, plus x, right? Minus j, 5 times 1 is what? 5, minus, this minus here is not the minus we have here. The minus is in the formula already. Minus x times 2, 2x, right? Plus k, cross multiply, 5 times minus 1. Okay, sorry. Minus 2, that gives us plus 2x, right? So we have k, 5 times minus 1 minus 5, minus 4 times 2, 8. So here we have 4 minus x. So let's open the bracket. This is bracket, sorry. So 4 times I, 4i minus 4x. Are we together? Oh, sorry. Minus ix. So here we have minus 5j minus 2jx plus what? Minus 5k minus 8k. let's subtract this. Minus 5 minus 8. Minus 13, right? So yeah, let's say we have minus 13k. Are we together? So I hope everything is. So what's the next thing to do? So here we have 4i minus 5j minus 13k minus ix minus 2jx. So can we have questions like this? What's the next thing to do? Let's check. Okay, let's factor x from this side first. 4i minus 5j minus 13k minus x. What do we have there? I minus 2j, right? Let's see. Sorry, plus 2j. What's next? Equals to 0, right? No, we are looking for the value of x. Cross product there equals to 0. Okay, I think now we have minus x I plus 2j equals to what? Is 0 minus 4i minus 5j minus 13k. Are we clear with that? So here we have minus x I plus 2j equals to what? Minus 4i plus 5j minus what? Minus 4i, yeah, plus 13k. So we have our minus x, or let me say x equals to, divide both sides by this. X equals to minus 4i plus 5j plus 13k divided by what? Minus I plus what? Minus I minus 2j. Now if we use I to open the bracket. Who is confused? Who is confused? I hope we are clear to this part. We are not done. No? So here now we have what's the next thing? I'm checking if there's anything we can do for that. Okay, let's delete this minus first. S equals to minus 4i minus 5j minus 13k over minus I plus 2j. So minus cancel minus. So S equals to 4i minus 5j minus 13k over I plus 2j. So let's see. I think that should be the answer. This is the final answer. Are we clear with that? You have a question? Yes. Yeah, it's 8. No, if you have A, B, C, D, the determinant is A times D minus B times C. Minus is in the formula already. That's why we're having minus here. Assuming it's minus 8, this will change to plus D. So this is the value for our x. Is that clear? This is the value for our x. So that's, you see that if we plug in everything here, that x here, and we take the magnitude, and we solve rather, everything is going to be equal to 0. This is the value for your x. So I hope everybody understands. Do we get that? Any question? If you are sleeping, stand up, go and jog, and go out. You see fresh air, because we have not done anything now. Can I clean the body? No. Yeah, let's sit down. Well, not getting a whole number is not a taboo. Are we together? No, unlike when we did dot product, I think we get 4 or 6. Not getting something like that is not abomination. So that's just the value for your x. Okay. So let's put that down before we proceed. So like I said, if they are perpendicular and you have a missing coefficient, use dot product, equate it to 0. If they are parallel, use cross product, equate it to 0. I hope that's clear. No, don't use parallel, perpendicular. I mean, sorry, cross product for parallel, dot product for perpendicular. Both equals to 0, equals to 0. Do you get? When they are parallel, when two vectors are parallel to each other, their cross multiplication equals to 0. When two vectors are perpendicular, their dot multiplication equals to 0. So when it's perpendicular, use dot product. When it's parallel, use cross product. And make sure that both are equals to 0. Can I clean the board now? Just 2 hours or 3 hours. We should be done. Okay, 2 hours for English. Let's just do 2 hours. So we have more time with manual notice. Okay, let me see the slide. Let me see what we may need to. There's no much on vector. There is no much on vector. Sorry. Alright. You have question. Is it UI question? UI question. Okay, can I clean the board? Yes. This is 102 or what am I saying? Okay, previously 101. I thought LFP was better. So question 3 says, in a football match, the ball undergoes 3 consecutive displacements D1, D2, and D3 in meter before the goalkeeper stop it. If D1 equals to I plus 3j and D2 equals to 2I plus 3j and D3 equals to minus I j, the resultant displacement is, are we together? So we have to find the resultant displacement. The question is actually simple. Can I clean this? So I'm going to read that question again. 3, read it out, please. So let's find D total. D total is what? D1 plus what? D3. And that gives us what? I plus 3j plus 2I plus 3j plus minus I plus what? J. So our D now equals to what? I plus 2I plus minus I. 3j plus j. This is our D total. Now let's find the magnitude. Since resultant displacement, let's find the magnitude. So here we have dt equals to square root 2 squared plus what? 7 square, and that gives us what? Root 4 plus what? And that's what? Equals to 7 point what? Is that option there? What's root 53, please? Is it 7.4? Let's say 7.3. Is it there in the option? Is there in the option? That's the answer. Are we together? So if we also ask for the direction too, just use your theta equals to what? Tan inverse of 7/2 y over x. Is that clear? Okay, like there's still one more question there. Yeah, what is that question for? Is it same? Okay, let me see this. Are we done?
No.
I hope we are still following. Or we've slept. Those who are watching online. There's one lady that was shouting fire the other time. Where is she? Debbie, Ibo ló wà. Can I clean the board? Can I take the board? And please, for your physics, I can assure you, if you read and you know what you need to know, there's no problem with physics. The only problem is tricks. Physics exam in UI or even test, they are not hard. The only thing is there's just tricks, traps. That's all. That's all. And you can do an exam or even a test, you feel like with what you did, you shouldn't score less than 25/30. It's actually over 60, they multiply by 2, but they are 30 questions. But when the result comes out, it can be seen like 15. Because there are traps there. The questions are not actually hard. There are traps there. Like our first test, the first test I did in 100 level. After this test, I was expecting nothing less than 8 or even 9/10. But when, at the end of the day, when we were seeing answer, 8 begins to reduce to 7, 7 reduces to 6. And at the end of the day, it amounts to 12/20, 6/10. So, but we begin to argue. At the end of the day, 6/10. So, all those, especially those minus and plus. The main issue with this course is minus and plus. Please take note of that. They are very, very important. And those your secondary school, most of them will not work here. Because there is a particular question in our test. And normally in our secondary school, the answer should be positive, as we always do. But in vector, yeah, the answer is negative. So take note of that. Now, and that's what happened in your first test then. This argument. Plus or minus 2 meters per second square.
Oh, yeah.
The answer is minus 2 actually.
Minus.
The thing is that, you know, I've already released my answer even before Prof. Awed disclosed it. I hope we are aware of that. I picked minus 2. The issue is that, see, acceleration equals to deceleration. But acceleration will only be deceleration whenever this guy is negative. They are not different vector, like they are the same vector. There is nothing like acceleration is different, then deceleration is separate vector. There is nothing like that. Both of them are the same thing. You know, you differentiate velocity to get acceleration. Same thing, you are differentiating velocity to get deceleration. Just that once this guy is negative, then by identification, your answer is deceleration. Do we get that? Once the acceleration is minus, you are actually, by identification, not by substitution or by whatever, by identification, automatically, this is deceleration together with the negative sign. So that's just it. Please help me to open your phone. And don't be shocked. Prof. I can even tell you the positive and the man will still be right. Though the answer is negative. Anything can happen in UI. And I actually like the man. The way he said this question is very intelligent. Normally, you should have asked you for acceleration. And you have picked negative, isn't it? If you ask for acceleration, your answer is t minus 2. I hope you know. Okay now. If you ask for acceleration, your answer is t minus 2. Deceleration, your answer is also minus 2. Okay. Whenever you have negative acceleration, A equals to B equals to that negative. If you ask for acceleration, your answer is minus 2. Or deceleration, your answer is t minus 2. So your answer can only be acceleration alone whenever you have what? Positive. Whenever you have negative, this. So whatever they ask here, whether A or D, the negative is your answer. Please take note of that. It's kind of, what is this man saying? Well, that was just well, I was happy when I had this minus 2. So here number 4, we have is on sensing danger. I pray you don't sense danger. On sensing danger, 2 birds A and B fly away from the same nest with velocity. On sensing danger, 2 birds A and B, 2 birds A and B fly away from the same nest with velocity VA equals to I plus 4J plus 3K and velocity VB equals to 4I plus 2J minus 4K. Relative to a stationary observer. Relative to a stationary observer. How far apart are the 2 birds after 5 seconds? The funniest thing I've had during that test is that when people were arguing plus and minus 2, some people even feel when they're arguing plus or minus 2 meters per second, some people answer in kilometer per hour. So those are the don't even have anything to argue about. You just keep short. Let me watch it. And for real, it's very easy for you to pick kilometer because even that distance is given in kilometer. I think so, right? So you just that man, God will help us. So we have to find what? What are we asked to find? How far? So that means we have to find the distance apart, right? Now, there are 2 ways to solving this question. It's either you first of all find the velocity apart. Do we get? Yeah. Can find the velocity apart, or you find the distance. You know, distance, velocity equals to what? Displacement over time, right? So the distance apart, you can also call it the displacement. Do we get? The distance apart. Like even though whether they are flying in a straight line or not, if they are flying even like this, this is the distance apart, which is still the displacement. Am I communicating? So the distance apart is our displacement. So velocity equals displacement over time, whereas your displacement will now give you what? Velocity times time. So it's either you find displacement here first, velocity times time, and you also find velocity times time. Then you subtract them. It gives you your distance apart. Are we together? So or you find the velocity apart, then multiply by this time to get your distance apart. Either of the two, you still get the same answer. So I prefer doing the velocity apart. So velocity apart, and take note, whether you do VA minus VB or VB minus VA, you get the same answer. Let's see, because here now we need magnitude. So when you are doing square of that thing, negative will vanish, isn't it? So let's say VA minus VB, the velocity apart, that gives us what? I plus 4J plus 3K minus what? 4I plus what? 2J minus what? 4K. I minus 4I. minus 3i, right? 4j minus 2j plus 2j. 3k minus 4k plus 7k. So our magnitude of VA minus VB, since we need magnitude, whether VA minus VB or VB minus VA, we still get the same magnitude. Equals to square root of what? Minus 3 square plus what? 2 square plus what? Equals to square root of what? 9 plus 4 plus 49. If there is minus anywhere, you still have the same thing at the end of the day. So anyone you do, whether VA minus VB or VB minus VB. So this guy gives what? That's 62, I mean. So that's what? 7.874. So let's say 7.9 meter per second. Are we together? For our velocity. Now, since this is the velocity apart, so now our distance apart equals to velocity apart times what? Times time. And that gives us 7.9 multiplied by what? What's the answer? Is that in the options? 39 point what? 37 meter. So write this so that we also use another method. We still get the same 39.37. Let's write that down. Which one I should explain? When that your test question, your deceleration can be positive if you are given your Cartesian plane. Yeah. Do we get what I'm saying? No. The answer is negative, but it can be positive if you are told that the body is moving maybe towards west or south. It depends. So you now be using the sign of the graph to multiply your final answer. Do we get? Assuming at the end of the day it falls on this side, this is negative x-axis. So you now have negative times negative to give you positive 2. So since you are not given something like this, so the answer remains minus. But if I give something like this, don't forget that tomorrow your answer could be positive. So it depends on the structure of the question. So that's vector for you. Are we done? Can I clean the board? I love this course actually. It's very interesting. Can I clean it? Phase 101, phase 102, they are calls that you and your classmate you will fight. Pick one answer, you pick another one. And nobody won't grip for each other. So here we have these are VA, these are VB. So let's find our, and this guy equals to velocity times what? Time, have we? So let's say dA. Our dA is VA times time. Our dB equals to what? VB times what? Times time. Let's assume this is distance now. Let's assume this is distance because we are going to subtract them at the end of the day. So here we have our VA is I plus 4J plus 3K. What's our time? 5. Our VB equals to what? 4I plus 2J minus 4K. What's our time? So 5 times this. 5I plus what? 20J plus what? 15K, right?
20i.
So we have 20I
10j
plus 10J
minus
minus what?
what? 20k.
20K. Now let's subtract. If we subtract, what do we have? Let's assume we are subtracting this from this. Either of the way, you still get your answer. 15I
10J.
Is this what I should do? I'm coming. I don't think this is what I should do. Something is missing. No. This is not the other way. Let me just try. Okay, sorry. This is what we should have done. Let's find the magnitude. This gives us 1 square, right? Plus what? I'm coming. Let me check. Okay. This is 5i plus 20j plus 15k. This gives us 5 square plus 20 square plus 15 square. Root 400 plus 225, 625 plus 25, 650. I'm coming 20i plus 10j minus 20k. Root 400 plus 100 plus 400, are we?
Yes.
That gives us root what? 900. What's root 650? 0.49. What's root 900? 30. Okay. They are not. To subtract them, they are not. Something is. Maybe when I remember that, just keep with this for now. When I remember that, I will come back to it. Let me not waste our time. I think I should. But I know we have 2 methods of solving it. But let's keep with this first. The next question. Let me not waste time trying to remember. That guy said, I think you said you have a question. Okay, let's do that. I hope it's UI. Is it UI question? Number what? We've done this in the last class. But for the sake of those who were reading for COS then that were not around. Yeah, have we done that COS now?
Violation.
1/3 violation. Well, I'm glad to tell you that man did not even have time like Math 103 lecturer. Math 103 lecturer, he can traumatize students. For those of you who will be doing 103 second semester, his own is more than COS lecturer. I'm praying to God that they will not watch this video, sir, to see what I'm saying now. His own is more than the man can give he will give classwork about like let me just say no NFLT will be full. He will give us classwork and he will ask us to submit. We checking row by row. You want to confirm if you did not write for your friend. You call on your name per row. You call your name. If he notice that the amount of submission is more than the amount of people sitting in a row, it's either he cancel everyone's paper or he wrote for another person, fish him out. And once you fish him out, you are going to SDC today. The man asked that if I 1,000 students that did the test and exam, we did different questions. He said different questions for everybody. It was though I was not in the center in invigilator, but I heard that even saw some people telling themselves, we did not bother to say, but like for your own good, you better stop telling yourself. It was after the test we knew that we did the different thing. It was after the test. Not that it's actually different, but your own number one could be 2R. This one person will be 2x. And your own could be 2R plus 7j. This one could be 2x minus 7y. It scattered everything. So the man has time. The man has time. Like he has time. So we have two boys. Two boys pull a toy with force. Pull a toy with forces 10 Newton, 10 Newton and 15 Newton, inclined at 60 degrees to each other. 10 Newton, 15 Newton, inclined at 60 degrees to each other. Find their resultant in magnitude and direction. After this, we move to another topic. I shouldn't treat this, but let me just. So make it your parallelogram. You can still say the parallelogram of vector self. No school fees is there. Yeah, now we have to find the resultant in magnitude and direction. R. Like I said, know this cosine rule. R square equals to A square plus B square minus 2AB. Cos what? Okay. Cos whatever we have there. The angle that is facing R. 180 minus theta. Or let me just say cos R. Just avoid. Now, cosine rule is, let me bring out this triangle. 15. Know this 10 is equal to this place. R. The angle we use here is the angle that is facing R. Are we together? For cosine rule, the angle here, whatever side you are looking for, the angle here will be the angle that is opposite to that side. So which means, if you want to use cosine rule, the angle we'll be using here will be this angle. How do we get this angle? 180 minus theta. The theta given to us. But you don't bother yourself with this one. Just use this guy direct. R square equals to A square plus B square plus 2AB cos theta. So don't use that idea of cosine rule, just use the other one. Use the angle between the two forces. When you use it, use addition. 2AB cos theta is same thing as minus 2AB cos 180 minus theta. Both of them are equal. Are we together? 2AB cos theta is equal to minus 2AB cos 180 minus theta. You can just try that. So always use this. Using negative is very easy to make mistakes. So always use this. Whereby your theta is the angle between the two. But if this is not a parallelogram law of vector, if this is just normal triangle, use your cosine rule. Do we get? If it's just normal triangle like this, if it's not parallelogram law of vector, and you are given something like you are given this side, whatever you are given, shall use your cosine rule. But for parallelogram law of vector, you can apply this guy. So now let's move. So we have our R square equals to 10 square plus what? 15 square plus 2 times 10 times 15 plus what? 60, right? Yeah. So we have 100 plus 225 plus what? 300. Because 60 is what? 2 times 10, 20 times 15, 300. So we have 325 plus what? 150, and that gives us what? 475. So R equals to root of what? And that gives us what? Have it? 21.8, isn't it? Newton. So that's the magnitude of the resultant. Now for the direction. The answer can be in 2 forms, but you cannot have those two in your option. So the direction could be in the 10 Newton force. Could also be to the 15 Newton force. So let's find the direction to the 10 Newton force. We also find it to the 15 Newton force. So let's call this our theta 1. No, theta 1 plus theta 2 is 60 degrees, right? So here we have our 15, 10, 15 what? Let's bring out this upper part. This 15 and this 10. This theta 1 and this is your resultant. Are we together? So label it A, B, C. So using sine rule, A over sine A equals to what? Equals to what? So you can pick this and this, or this and this, or this and this. Depends on what you are looking for. This we know we have this angle, isn't it? Opposite angles of a parallelogram are equal. If this place is 180 minus theta, this is also 180 minus theta. Here is what? 120 degree, right? Because our theta is 60. So this is our small a. The side facing the angle is like, if this is a, these are small a. So our small a is 21.8 divided by what? Sine 120, isn't it? Equals to, should we use C over sine C or B over sine B? You can't just use anyone. So we are using B over sine because actually this theta we are looking for. No, we don't have this one. So let's use B over sine B. That's what? 15 over what? Sine theta 1. So cross multiply. So we have 21.8 sine theta 1 equals to what? 15 sine what? Sine 120. So we have, thank you. Sine theta 1 equals to what? 15 sine what? 120 divided by what? 21.8. And that means theta 1 equals to arc sine 15 sine 120. 12.99. Are we? Are you sure? Let's just say 13 over what? 21.8. So theta 1 equals to what? Theta 1 equals to arc sine. This over this, what do we have? 13 divided by 21.8. 0. What? 5923. 596. So what do we have?
36.6.
36.6 degree. To which force? To the 10 Newton force. So this is the aspect we use. So you don't need to, if to the 10 Newton force is not your option, if your option is to the 15 Newton force, and this is what you did. You don't need to use sine to find your theta 2. Since you know the total angle there, 60 degree, right? Subtract this from 60. What will be your theta 2? 60 minus 36.6. That gives you what? So it's either you get 23.4 degrees to the 15 Newton force or 36.6 degrees to the 10 Newton force. I hope that's clear. Is that clear? But you cannot see the two in the option. You can't see the two in the option. So that's that for that. If you decide to say this is your 15 and this is your 10, for this one you get 23.4 there. So wherever you put it, you put 15 here, this theta 1 will give you, instead of this one we get, you'll be getting 23.4 here. So you still get the same thing. I hope that's clear. What's the next topic after vector here? Kinematic. It's actually interesting. What's kinematic? Kinematic is the study of motion without studying the force that causes the motion. Abi? So let me to open that 30 question. There are questions on kinematic here. Studying of motion without studying the force that causes the motion. Why dynamic is what? Studying both the force and the motion. Have you opened it? End the week. End the tag assistant. Have you opened it? I love it. Go and do push up outside. So here we have So I want us to do kinematic and relative motion simultaneously. This relative motion is one of the technical aspect of physics 101, but it's actually simple. Just understand. But initially, if I just come across relative motion for the first time, for you to understand it perfectly at that first time, that means you are a genius for real. Because it's actually tricky, but once you just understand, there's actually nothing there. You just have to sit down and understand that guy perfectly. So we do the two together. So I will mark those questions together. Questions. Question 7, 8. 17, 18, 7, 8, 17, 18. 23. Okay. So now, question 7, question 8, 17, 18, and 23. Those are the 5 questions on the kinematic and relative motion as regards the 30 questions I gathered. So let's start with that. Yeah, what's question 7? What's question 7? Question 7. A ball. Continue. That question 7. There is a 30 questions physics first year past questions that I gathered that one. Question 7. Well, that question just dictates its projector. A boy walks 4 meters. Please, I'm coming. Let me. Hello, can we? I hope we are following. Is everything clear? Hello. Oh yeah, I need a response now. All right. Oh yeah, continue. A boy walks 4 meters east. Now, well, we may not even need to draw diagram as regards this question, but let me just use diagram to explain. But there are some that you need to draw the diagram so that I can get the position very well. Now, initially before, so at times the way I used to do, if there are times that if I was told to do something like a boy moves 30 kilometers due north and 10 kilometers due south and 10 kilometers due east. The way I think at times, not any longer, is that okay, 10 kilometers due north, 4 kilometers due east. Now put it here. I am not drawing your resultants like this. You are wrong. If you are moving 10 kilometers due north, you come and pass east. Do we get what I'm saying? No. They say a boy moves 10 kilometers due north, then 4 kilometers due east. You are only given 2 movements. If you come back, you will move another 10 kilometers, which is not in the question. So it's not 10 for here. From that point, you move your east. Do we get? So 10 kilometers due north, then 4 due east. So at times me, I will come back and do my 4, which is wrong. Because at that instant, you move another 10, which is not in the question. So yeah, now, let's continue.
The boy was 4 meters east.
4 meters east,
And 3 meters south.
3 meters south. Are we together? 4 and what? 3. So we don't need all this. Even though you want to draw your cardinal point, 3 meters south, you can draw another cardinal point here. 4 meters east, then 3 meters south. Yeah, that's south now. North, south, west, east. South is downward. Are we together? What is what?
What is the magnitude and direction of the displacement?
What is the magnitude and direction of what?
The displacement.
The displacement. You can do that, Ojoro, and you still get answer. It depends, but please know how to draw it. East, then south, not east, and you are moving your south like this again. Come back to move your south, and you do this. If you do this now, you may have issue with your quadrant. Are we together? Just draw it as I've explained. That one is perfect. You can do this at time, and by lucky you get the answer. But this one, there's no by lucky. You surely get your answer. So these are resultants, right? R squared equals to 4 squared plus 3 squared. Obviously, our R is 5, isn't it? So we have R equals to square root of what? 16 plus 9. That's root of what? 25. So R equals to what? 5 meters. That's magnitude. What of the what's it called? The direction. The direction could be in diverse way. You can be hearing east, south, you can be hearing anything. In fact, you can be hearing a lot of degrees. It depends, but just that you can't see 2 correct answers in the option. That's just it. But you can see a lot of answers that you can get yourself by solving it. That will be in the option. Now, let's find the direction. You can draw as much cardinal point as you can draw. As can draw. So yeah, my directions could be this to the west. It could be this to the north. My direction could be this to the south. Are we together? It could be this to the east. Do you get what I'm saying? It depends on any way I take it. The direction of this R could be this guy to this south. I could use this angle to the east. I could use this angle to the west. I could use this angle to the north. So anyone. Now let's find the direction as regard. Let me just pick one of them. Which one should I pick? I can pick anyone, but let me use this guy. Let me find the angle here. Yes, it is easier to use the inside. Do we get? But whichever way you can do. So here we have 4, we have 3, and we are looking for what? Theta. So, and we have our 5. How do we find theta? Sine or cosine rule? Or SOHCAHTOA, anyone? What are we going to do? You can use SOHCAHTOA now. So you can use sine, you can use you can use car, you can use TOA, since you have all the sides. So let me use, it's been a while I've worked with TOA. Let's use TOA. So we have tan theta equals to what? Opposite over adjacent. What's opposite? 4 is facing the angle. What's adjacent? 3. So we have theta equals to tan 4 over 3. That's 1.25, are we? 1.33. So theta equals to tan 1.33.
3.1.
3.1 degree. Are you sure?
53.1.
I for fear. You use so or car, you still get 53.1. Now this 53.1 is so where? So our resultant equals to 5 meter, 53.1 degree north west. Notice the angle we found, right? Coming from north. If this is the place you find, that will be west north. Are we together? Okay, subtract this guy from 90. What do we get? 36.9, Abby. That means here is 30. So your answer could be 5 meter 36.9 west north. Are we clear? Do we understand?
Yes.
So we look for this guy to get 50.1 because it's inside this guy. It's enclosed to the north part, so it should be northwest. But if you subtract from 90, because actually this right angle to get this guy is if you close this triangle here, this is enclosed to the west. So this is the 30.9 west north. I hope that's clear. That could be your answer, and this may not also be the option. So you can also find this. If you want to find this guy becomes your what? Your theta. Are we together? So now let's find this. Is there option there? Is there anything like this in the option? No. So let's fall within the range of the option. So let's find theta here, theta. So yeah, let's use sine, or let me use TOA. So tan theta equals to what's our opposite? What's our adjacent? So we have theta equals to tan inverse. 3/4 is what? 7.5. What's tan inverse of 0.75? 39. Let's say 36.9. Abi? 36.9 degree. Now this place is what? East south, Abi? Or south of east? 36.9 degree east south. Is it in the option? No. Okay, let's subtract this guy from 90. You subtract 36.9. Do you understand how it is east south? No, it is enclosed to east, right? So it is east south. Now let's find the one that is enclosed to south. So that we call it southeast. If you subtract this from 90, what do we get here? So it is our resultant now will be what? 5 meter, 53.1 degree what? South east. Is it in the option? South. What's in the option? 15.3 southeast.
Yes.
I say it's not in the option. What's 53.3? What's 53.1? So it's in the option. This is the correct answer. Are we together? All these are correct. But it depends on what you have in the option. Just know what to do. I hope it's clear to everybody. Any question?
Knows the locating of points like southeast and locating of points.
That is not clear. Let me draw this diagram again. So this is your resultant. If you find this angle, you know how to find this angle here. Theta. Now you bring it at theta. Use either so or ka or toa. You find this angle, then that is the direction of your resultant. But since this angle, this angle now is inside the line of the resultant and not. Are we together? And not. So whatever you get here will be northwest. Am I communicating? Here now, if I find my theta, maybe my theta is 30 degrees. Then this 30 will be 30 degrees northwest. Because it is from north here. It is enclosed within north and the resultant. So it will be northwest. But if I want to get this, if that is not the option, if what I have in the option is west north, that means I have to look for this place. Do you get? So how do I look for this place? Is this right angle? Subtract this from 90. That means this place will be what? 60 degrees. I know this 60 degrees enclosed within the horizontal and west. So it's either 30 degrees northwest or 60 degrees west north. Do you get? You still don't get. Okay, let me just solve it directly to what is in the option. Maybe I'll use that to explain. Five, 4, 3. So now, see, the direction of my resultant can either be this part or this part. I can pick any part, this or this. But when we do this, they are not in the option. That's why we solve for this part. So let's focus on this part now. Find the angle here, theta. Are we together? You find the theta here. Let's find it. So here we have theta 4, 5, and what? 3. So sin theta equals opposite. That's 3 over cosine of 5. Theta equals to sin inverse. What's 3 over 5? 0.5. Eh? 3 over 5. Okay, wait. So our hypotenuse is 5 now. 3 over 5 is what? 0.6. Just 6, are we? Ask sine 0.6. Ask 36.9 degrees. Listen, though. What do we get here now? 36.9 degrees. But that 36.9 degrees, notice it's not south, west, and what? This line is east, isn't it? That 36.9 degrees is enclosed within east and the resultant. Do you get? So that means the angle is coming from east. So now your resultant is going to be 5 meters with a direction of 36.9 degrees east. No, it's actually coming to south. East, south. So the other one now, because there is nothing like this in the option is southeast. That means we need to find this place. The angle that is enclosed within south and the resultant. By subtracting this from 90 degrees, no, everything here is 90, right angle. So this place will give us 53.1. So here now we'll be getting what? 53.1 degrees southeast. Is it clear now? Or east of south? No, east of south is same as southeast. I hope that's well understood. Any question? We have question 8. Let's solve question. We have not started 102. We are sleeping. What's time? I've recapped already. I hope it's clear now. What's time? 12:41.
12:49.
49. It's not late yet now. We are stopping by 5, isn't it? Can I clean the board? Can I clean the board? Other question 8. After this 2 topic, we are moving to 102. Question 8. Math 102. Question 8.
An insect walks 50 centimeters in a straight line along a wall. If its horizontal displacement is 25 centimeters, what is its vertical displacement?
An insect walks
50 centimeters in a straight line.
in a straight line.
along a wall.
Uh-huh.
If its horizontal displacement is 25
We
centimeter.
are given horizontal displacement to be what?
25 centimeter. What is its vertical displacement?
X. That means the work of the insect is like this. Are we together? We are told, okay, let me not do it like this. Whether this or this or this, everything is straight line. Is this not straight? Is this straight line now? Oh, see, the thing is that, how can I say it now? Some of you have the idea that if there's a straight line, there's either horizontal or vertical.
Yep.
No. And actually, this could be even horizontal. Because somebody may decide to be watching like this. If I stand slantly now, it's horizontal to me and it will be vertical, it depends. But since I've been given now, if I try to draw my this thing like this, maybe the insect works on a straight line, and I was told that with 2.5, are we?
25
centimeter. Oh, yeah, read again.
An insect walks 50 centimeter in a straight line.
Straight line,
Along the wall.
If
it's horizontal displacement.
If it's horizontal displacement, so where will you now put the horizontal? Are we together? But I may even decide that this is my horizontal. Depends. I may be watching from this side. So, but to just avoid ambiguity, can just decide to say, okay, draw those horizontal and vertical first. We are given the horizontal displacement to be what?
25 centimeters.
25 centimeter, and we have to find the vertical displacement. It can be here, it can be here. So that means the insect work like this. Insect work like this. This is still a straight line. It's straight, just that it's slant. So we have to find the. So what is the distance covered by the insect?
50 centimeters.
50 centimeters. There is nothing on our Pythagoras and we are done. The next question. Do we have issue with this? No. Pythagoras, we are done. We have the next question.
Two insects
Two insects
have velocities VA equals to I minus 4J.
V equals to I minus 4J
minus 3K.
minus 3K.
BB equals to 4I
4I
plus 2J
plus 2J
plus 4K.
plus 4K.
Find distance after 2.5 seconds.
Find the distance apart. I think the question is not complete. The distance apart after 2.5 seconds. We've done something similar earlier, but that one is 5 seconds. So let's not waste much time on that. Question 23. Question 18 rather.
A boat swims at 0.8 meters per
Relative
second.
velocity. I love that. Relative motion. And I'm going to teach you some different aspects of relative motion. Very, very interesting. Let me clean this part. Oh yeah, read down.
A boat swims at 0.8.
Is 23 also relative motion? Relative value. That's it. A boat swim. I want to write the question on the board so that a boat swim
at
at
0.8 meters per second.
8 meters per second.
In a river.
0.8.
In a river flowing at 0.4 meters per second.
In a river flowing
at 0.4 meters per second.
0.4 meters per second.
Find total time for 0.5 kilometers.
Find
Total time for 0.5 kilometers.
Find
Total time
the total time for total time taken to cover a distance of what?
0.5 kilometers.
0.5 kilometers.
Upstream and back.
Upstream and downstream. Upstream and downstream. I use AI to extract the question from past questions. So AI is the guy who doesn't know what he's doing. He just remove some words from. Sometimes you can give the guy like 3 lines, we turn it to like 1 line. Just remove. He'll be giving you parameters alone. So I think this is like the original question. A boat swim at 0.8 meters per second in a river flowing at 0.4 meters per second Find the total time taken to cover a distance of 0.5 kilometer upstream and downstream. Now, this is our river. Let's say this is the ground level. This is the ground level. This is river. I just want to use this to explain very well. This is the ground level. And this is the boat. Hello, are we together? Now, a boat swim at 0.8 meter per second in a river flowing at 0.4. Okay, before that, now we have three velocities here. The velocity of the boat relative to the river. The velocity of the river relative to ground. So assuming the ground is moving, there will be something like the velocity of the river is going to change. But since the ground is not moving, let's take it that way. So we have velocity of the boat relative to river, the velocity of river relative to ground, and velocity of boat relative to ground. So we have, please help me to wake everybody. Wake up. Go out, go and do push-up. Like you just do 50 push-ups. So we have velocity of boat relative to ground. We also have velocity of boat relative to river. We also have velocity of river relative to what? Ground. Now let me use distance to illustrate everything for you. Let's assume this is distance. Actually, we are talking about velocity, but I just want to use distance to explain. Now, the distance of this boat to the ground level, all this distance is going to give the distance of the boat to the river surface plus the distance from the river surface to what? To the ground level, isn't it? So velocity of the boat relative to ground will give you velocity of boat relative to river plus what? Velocity of river relative to what? Do we get that? I hope that's clear. Everyone, just use this distance idea. Distance from here to here, distance from here to here equals distance from here to here plus here. Same thing applies to velocity. Velocity of this boat relative to ground equals velocity of the boat relative to the river plus velocity of the river relative to the ground. That's what I just did. So now, that's all we need. But this time we just need to be checking the positive, the negative. Now, river, naturally, have you seen river flowing upward before? Like, if the ground is like this, water will become like this. Water is always downward, isn't it? Water is always flowing downward. Am I right? We are dealing with physics. The law of physics is constant everywhere. So water is always flowing towards gravity, not against gravity. So if water is, except the case of Jesus Christ, that he walked on water. So law of physics is disqualified at that moment. So now, if water is always flowing downward, that means if you are going upstream, what happens to motion? That means the flow of the water is against the motion of the boat, right? The boat and the water, they are moving in opposite direction. So that means for your VBG, the velocity of boat relative to ground equals to, for upstream, when you are going upstream, your VBG is actually the velocity you want to use, because it's like the resultant, like the boat to the ground. So your VBG is going to give us your VBR, since velocity of boat relative to river is in opposite direction to the velocity of the river relative to ground, because this one is down and you are going up. So we are doing what? Minus VRG, isn't it? When they are opposite, you subtract. Let me not even put plus again. Sorry for that. If you are going upstream, you are subtracting. So it's still addition, but one is opposite direction. I hope that's clear. VBR minus VRD. Now for downstream, your VBG plus what? VBR plus what? VRD. Why? Because now they are going what? In the same direction. So you add. Opposite direction you subtract. You are still applying the formula. Opposite direction you subtract. The same direction you add. Now for upstream, VBG equals what's our VBR? Velocity of a boat swim at 0.8 meters per second. Now listen, this is another issue now. Is this the velocity of the boat or the velocity of the or the velocity of the boat relative to the river? That 0.8. Let me check something. I'm coming. Yeah. Is this the velocity of the boat? You know, relative velocity is different from original velocity. Is this the velocity of the boat or velocity of the boat relative to the river? Because now we have been told that a boat swims at 0.8 meters per second in a river flowing with 0.4. So whatever might have happened, whether the river has opposed it or not, this velocity at which is swimming now. Are we together? So that's the relative velocity that has been given. Do you get what you are saying? A boat swim at 0.8 meters per second in a the river already flowing with this. Yes, it's still swimming with this. So the relative velocity has been given already. Am I communicating? So this is the velocity of the boat relative to the river, 0.8 minus what? In a river flowing at 0.4, I'm coming? Yeah. In a river flowing at 0.4 meters per second, we are given 0.4. Wait, there is something I'm checking. That's correct, but I'm trying to explain something again. Okay, yeah. So we have 0.4, right? Meter per. Now for downstream, our V equals 0.8 plus what? And that gives us what? 1.2 meters per second. Now let's cover 500 meters. You multiply by 1,000, 4.5 kilometers. So now what's time? We have to find the time. Time taking, velocity equals to what? D over T cross multiply. V equals to what? D. That means T equals to what? D over velocity. Now to go upstream, we have 500 divided by what? 0.4. And that gives us what? That gives us 2,000 seconds, which is 2 times 10 raised power 3 seconds. To go downstream, we have 500 divided by what? 1.2, Abi. That gives what? That gives what? Please tell me to check the option. Is this answer there? 416, Abi. 0.7 seconds. Shape this over this. It's not 2,000. One what? 1250 seconds. So this guy gives us 1.25 times 10 raised power 3 seconds. So the other one, 500 over 1.2. There's something I'm trying to, but it's not. I think it's not relevant. So let's just. So this is 500 over 1.2. This is upstream. This is downstream. So these are the two answers. I hope we understand. Any question? Any question? Now, the case is different. If you are given two velocities, so I just want to have the question with you. Now, people used to mix things up because if you are given Maybe you are given VA equals to let's say 2I plus j. Maybe they give it in magnitude or in vector. And VB equals to I minus 3j. And you are asked to find the velocity of A relative to B. Velocity of A relative to B. This case now, listen, your VAB is going to give you what? Oh, yeah, it's going to give you VA minus VB, while your VBA is going to give you what? VB minus VA. This velocity of A relative to B, when you are given two different velocities, this velocity of B relative to A. There's one more I want to add. I'm coming. Yeah, also, for this part, please listen. When you are dealing with force, when force are opposite to each other, what do? The resultant force is what?
Hi, good morning, everybody. For those who are educators and non-educators, irrespective of your faculty, please, if you want to ease yourself, go to the faculty secretariat, the building with very lighted blue, very small building, or ask educators around to get the key to the toilet. I don't want to catch anybody being around. This night I've already got to people already, and I've been lenient enough. If I catch a toilet, but please, I'm begging you, so that you will not beg. So please and please, go to the secretariat and collect the key to use the restroom. Whether you are an educator or not, they will give you. Do you understand? Thank you very much.
Please don't be around, please. Just get to the secretariat and collect the key. Go to the toilet. So now for force, if force are in opposite direction, the resultant force is what? Subtraction, right? Please listen, pay attention to what I want to say. But if velocity are in opposite direction, the resultant is addition. Do we remember that? Yeah. But yet, we use subtraction here. Why? And that's what I want to explain. If force are in opposite direction, you subtract. If they are the same direction, you add. But for velocity, for relative velocity, if they are in opposite direction, you add. If they are in the same direction, you subtract. For that relative velocity, opposite direction add, the same direction subtract, is valid here. It's only valid here. Do we get? But for this guy, for this part, not that it's not valid, but this part, we are relating to force. That's why we have this subtraction for opposite. This how we are relating to force. Let me explain. When a boat is moving, now when we are talking of relative velocity, when velocity are opposite, you add instead of force that you subtract. In that case, is just in case of it looks like kinematic, whereby we are not considering the force that is causing the motion. Am I communicating? We are not considering the force. It's just like, okay, I'm moving like this, and you are moving like this. We are not touching each other. So our relative velocity, the fact that we are opposite to each other, and we are doing addition. If we are going in the same direction, we are doing subtraction. But for this guy, the boat is on the river. A force is attached. Because if the boat is trying to go up, the river is trying to bring it down. Do you get what I'm saying? So in that case, like force is involved. That's why we are still applying the idea of force. Opposite, you subtract. Do you get what I'm saying? Same direction you add. But for normal relative velocity, that force is not applicable at all. Nothing is bringing this, or nothing is trying to oppose. There is no current of the river that is trying to oppose the swimming of the boat. For your opposite velocity, you do addition. Do we get what I'm saying? Yes. For same direction, you do subtraction. What am I going to say? Yeah. Same direction, you do subtraction. And this is just the logic. Why are we adding when velocity are opposite to each other? Now, if you are coming, and I'm also coming towards you, the way I'm looking at you is faster. You are approaching me very, very fast. Are we together? No, if you are coming like this and I'm also moving very close to you, you are approaching me I'm seeing you walking towards me very, very, very fast. So that's why the relative velocity there is addition, it's not subtraction. Because if it's subtraction, that means the relative velocity will be very small. But in a normal sense, the way you're approaching me is very fast, it's not small. So that's just the reason, sha. Let's just forget that. So relative velocity for opposite direction is plus. For the same direction is minus. Please take note of that. Opposite is plus, same direction is minus. But for this case, you still apply the idea of force because here now, opposition is involved. Like something is trying to drag you back or something is trying to help you move faster. Do we get that? A force is trying to drag you back. For upstream, a force is trying to drag you back. That's why we have to subtract. And for this VBG, this is velocity of both relative to ground. It's not. Should I even use that test? Okay, let's lay that aside. Upstream, a force is trying to drag the boat, to drag it back. The boat is trying to move faster than 0.8, but there's an opposition that is trying to drag it back. So that's why we have to do subtraction here. And that's why and even though they are opposite, that's why we have to subtract. Unlike here, that we have to add. Though the sign is minus for vector, you will see where the addition is necessary now. Because we are seeing minus here, I think that's one of the things that is confusing some people. Now let's come and say something. What's that? Read question 23. Let me see whether it's related to that. So I can show you why one will be addition, one will be subtraction. Question 23. Can you read it?
Cat A moves at 40 meters per second.
Very good. Cat A
moves at 40 meters per second.
Moves at 40 meters per second.
Cat B at 30 meters per second.
Cat B at 30 meters per second. Opposite, yeah.
Find velocity of B relative to A.
Also, that question is not complete because we're given north or south, whatever. But let's just leave that aside. Find the velocity of what?
Of B relative to A.
Of B, so VBA. Which normal vector formula, even in mathematics, VBA equals to VB minus what? VA. Are we together? Now, where is it? Cat A moves at 40 meters per second. So you are going to take it as positive since you are not given your Cartesian plane. If you were told that cat A is moving in the south, so this 40 will be negative. Since this guy is opposite, that means the 30 will be positive. Are we together? But since you are not given south, so you are going to take the first movement as positive. So our A now, our VA equals to what? Plus 40 meters per second. The original question we were given Cartesian plane. So I think this one is, if not west, so this should be negative, then this should be positive. But since you are not given Cartesian plane, the first movement should be taken as positive. So our VB will give us what? Since it's opposite, that's what? Minus 30 meters per second. So now, since they are in opposite direction, what are we doing? Addition. Are we together? So we are doing now our VBA is going to give us what? VB plus minus VA. Are we together? At the relative velocity. I'm showing us the can I clean this one? Let me check if I'm not missing something out there. I'm coming. It's like okay, it's correct. So our VBA equals to, what's our VB? Minus 30 plus, what's our VA? 40. So the answer gives us minus 70 meters per second. I'm trying to check something. Please just give me a few minutes. I'm trying to check. Okay. This is not what I should do. Yeah. Yeah, I remember what I. So we are following the pattern. So the issue I explained earlier that if they are in opposite direction, please pay attention. If they are in opposite direction, that gives you what? Addition, have you? If they are in the same direction, that gives you what? Subtraction. Which, since they are in opposite direction, it means at the end of the day we have to get 70. Are we together? We have to. That shows that addition has taken place. If they are in same direction, at the end of the day we have to get 10. That's where this guy the application will be involved now. So, but we are still following this pattern because the formula for something, even in mathematics, this is the formula. It's not plus. But to show that at the end of the day, opposite direction will still resolve as addition. You see that even when we follow this formula, we still get 70 as our answer. Are we together? Now, VB equals to VB. What's our VB? Minus 30 minus VA. What's our VA? 40. So our answer is what? 70 meters per second. Which is still an addition of 40 and 30. Are we together? But this sign is just telling us that, probably from this minus or from whatever. So you can get this sign. But assuming we are given Cartesian plane, it's possible that there is no minus here. It depends. But just know that if they are in opposite direction, another thing to confirm your answer, even after following this mathematical expression that is correct, if they are in opposite direction and you're having 40 and 30 and you get 10 here, you have made mistake. It must be the addition of the two. Am I communicating? Because opposite direction relative velocity you add. But here now we are not doing addition, obviously. We are not just adding because there is a formula applicable for it. Applying the formula at the end of the day, you will still resolve as if you are doing your addition. Am I communicating? Just that, okay, signs can now come in. If they are in the same direction, you must get 10. As if you are subtracting 30 from 40. So the 10 could be positive, it could be negative. Just make sure you get 10. So whatever you do, at the end of the day, if you are getting 70 and they are in the same direction, you are wrong. It must be 10. It must look like you are doing subtraction. But still follow the formula. If they are in the same direction, VBA equals what? VB minus VA. Since they are in the same direction, both of them will be what? Positive, Abi. That's what? VB is 30 minus what? That's what? Minus 10 meters per second. Which still look like what? A subtraction. Do you get what I'm saying? So follow the mathematical formula, which you must follow. This one will help you to get the sign that will be there at the end of the day. Why this one will help you to know whether you are right or not. It should be 10 because you are subtracting. It should be 70 because you are adding. Am I making sense? Yeah. So that's that for that. So I think there is one more aspect. Okay, let's treat one question. There's one question in the slide, a passenger. Somebody should open the slide. Under relative motion. A passenger sits in a train, velocity of train relative to the roadside observer, all those ones. I hope you guys have not slept. Those who are watching from online, do we understand? Hello guys. Abi eti suni. Okay, all right. I hope everything is clear and this thing is my touchpad has been doing nonsense again. Yeah. This one is saying recap. They play. Can I clean the board? Don't worry, you watch the video later. Don't let me recap, I beg. No. Yeah, the last question. I should have recap, but we need to do mathematics very well, more than. So if you are sleeping, you have not started. Yeah, what's that question? A passenger. A passenger.
A passenger. Question what? Question what?
Kí ló ń ṣe àwọn eléyìí tó ń pariwo recap?
Question what?
I think we only have one question on passenger there. No, if you have time, I will recap that part, but let's read this question first. Oh, a boy, are we? A boy. Oh, yeah, actually, I know passenger is still there. A boy runs inside a train with a velocity what? VBT
equal to 4i minus 2j.
Continue now, is it the question? 4i minus 2j.
Relative to a passenger.
Okay, that's it. Relative to a passenger
Sitting in the train.
sitting
In the train.
in the train
When the train is moving with a velocity.
while the train. There is a relative motion question I said during my mock. I would love us to see that question before we start. While the train is moving with what?
With a velocity VTL.
V
TL.
TR, velocity of train relative
Equal
to
to 50i
50i
plus 30j.
plus 30j.
Relative to a roadside observer.
Yeah, relative to a roadside observer.
Find the velocity of boy.
Find the
Velocity of boy.
velocity of the boy
Relative to roadside observer.
relative
To the roadside observer.
to the roadside observer.
VBL.
Solution. Are we together? Pardon me, I don't have writing. Say yes. A boy runs inside a train with a velocity VBT, that's the velocity of the boy relative to the train, equals to 4i. Our VBT equals to what? 4i minus 2j relative to a passenger sitting in the train. Sitting in the train. While the train is moving with a velocity VTR, note VTR equals to VPR equals to 50i plus 30j. What is VPR? Velocity of the passenger relative to the. Please listen. This velocity of train relative to roadside observer. This velocity of passenger relative to roadside observer. Why are they equal? Because the passenger is sitting down. If the passenger is not sitting down, they can't be equal. You know, if this is a plank and I gum, maybe I use gum to attach something on the plank. I don't need to move what I attach to. If I move the plank, what happens to this thing? They move together. Isn't it? If I move this with 5 meters, this also will move with 5 meters per second. If this guy cover distance of 1 kilometer, this will also cover because they are joined together. So the passenger sitting inside the train have the same velocity relative to the roadside observer as that of the train relative to the roadside observer. Because what? He is sitting down. But if he is running, the relative velocity are different, even though he's still inside the train. If he is running, the relative, because something frame of reference in physics, if he's running, the thing is that the train now is carrying the guy. That's one frame of reference. The guy himself is also running. That's another frame of reference. So the velocity of the train is going to add up to its own velocity. See, you may look at it in a sense that since it's still inside the train, even though it's running, it should be the same thing now. But we are not looking at it like that. I'm looking for a way to explain it. So that you know that when he is running, the velocity is no longer equal. Because how can I put it now? I'm looking for a real life scenario that you will understand. Here now, running in the train, while the train is also moving. It's not, here we are considering velocity, not distance. No, assuming it's about distance cover, whether you are sitting down or not. Do you get what I'm saying? If it's about distance covered, whether you are sitting down or you are running, in as much you are still inside the train, like the distance is still the same thing. Do we get? But here we are talking of relative velocity, how you are observing somebody that is standing outside. When you are sitting, the way you are looking at someone standing outside is different from the way you'll be observing that person when you are running, even though you are still inside the train. I think that should just settle the case for now. Maybe when I have another idea, we are going to discuss that. So now, VTR equals to VPR if and only if the passenger is sitting down in the train. Sitting and standing is the same thing. If I just stand on a spot or sitting down, it's still the same thing. So VTR equals to VPR equals to this guy. So we have to find the velocity of the ball relative to the what? Roadside observer. Since the guy is running. So the velocity of the ball, we may not even need this in the question, but me, I'm just explaining in case another time. Relative to the roadside observer, since the guy is running, so we are going to have, it's just like, now this is it now. Should I use that diagram now? Will it work very well? Okay, this is the train. Normally, even there's a video I did, the answer is different from the one in the slide, but it's still correct. It depends. Now, what I did in the video is that I assume that the observer is observing the train from the front. Please, let's pay attention. I assume that the observer is observing the train from the front. Now, the train can be coming and you are observing like this. So that could be correct. But in the normal sense, observing from the back is more real. Because if the train is actually passing by, am I communicating? At the end of the day, the observer will actually be at the back of the train, observing. So observing from the back is more real than observing from the front. So the slide use observing from the back, which is more real. Because even though you are observing from the front, at the end of the day, the train will still pass you by. The last observation will still be from the back. So are we together? So we are observing from the back. So let's say the observer is from the back. So this is the train. So I want to use, now let's say this is the boy running in the train. The boy is running. Now I want to take the train as if it's here. I want to take the last part of the train. I hope this makes sense, yeah. Now the velocity of the boy relative to the train, let me assume this is it. Are we together? The velocity of the train relative to the roadside observer, let me assume this is it. This is roadside observer. This is boy and this is the train. Now the velocity of the boy relative to the roadside observer, let me assume that this is it. Do we get what I'm saying now? So the velocity of the boy relative to the roadside observer is going to give us the velocity of the boy relative to the train plus velocity of the train relative to the roadside observer. So here we are going to get VTR plus what? Velocity of the boy relative to the train, that's VBT. So that gives what? 4I minus 2J plus what? 50I plus what? 30J. 4I plus 50I. 54I, minus 2J plus 30J plus 28J. So that's for that. And if we are asked to find VRB, of the roadside observer relative to the board. Are we together? Don't forget VAB equals to minus VBA. Are we together? So this will give us minus 54I plus 28 what? J. That gives us minus 54I minus 28J. This is VRB, of which they did not ask us, but me, I'm just saying in case. This is VBR. Is that clear? Is that clear? Yes. Before we start mass, I will give you 5 minutes break. Go and do 100 pressure of outside. That's clear. I think they have one more question. That one is inside my mouth, so I can't be finding it. Ma? Why is it like this? VAB equals minus VB. No, here, what we find here is VBR. If you can ask us to find VRB, if VAB equals minus VB, then VBR equals minus VRB. Do you get it? Since our V, or let me say VRB equals minus VBR, and since our VR is this, minus VBR, you use minus to open the bracket. So we are done with physics for today. What's time now? Okay, by 1:40 we start maths. Don't sleep. Go and use it to do press up and walk around. In the course of walking around, go with your phone, you. There are thieves, so my academic director who came here recently, they stole his phone. Was he not a few days ago? Including the vice president's phone. 3 phones, 2 for vice president, iPhone inclusive. So please go with your phone. I will not be held responsible. So we are done with physics. So you guys just come back in the next 10 minutes for Math 102. So I'm going to cut the video now because I don't want to record 102 with physics. So just come back by 1:40 or 1:45. If you come by 1:40 and you can't see me, come by 1:45 for Math 102. So bye.